Hi everyone. Today we are going to understand the distance formula. First let us understand what is the requirement of this distance formula with a few cases. So let us take first case. If suppose we have 2 points, let me say point P and point Q, okay, they lie on x-axis. So let me draw a diagram to show you. So we have 2 points, say P and Q, they completely lie on x-axis. And I want to find the distance of PQ and keep this as origin. To find this distance, what we can do is, you can take the longest length minus the shortest length. That is, PQ can be obtained by OQ minus OP. This is how you can find the distance of PQ. Similarly, if you have along y-axis, 2 points are only on y-axis. So how to find the distance between them? So I have 2 points, 1 point here and 1 point here. Let me mark it as A and B. And both the points are on y-axis. So to find its distance without actually measuring, okay, so what I have to do is I have to take the longest length minus the shortest one. That is, the distance AB will be equal to OB minus OE. This is the another case. If suppose I have okay, if suppose I have the points on x-axis and on y-axis, okay, let me take this as A and this as B, okay, and I'm connecting these 2 points, fine, and this point let us take as origin. Now how to find the distance AB? As you all know, you have studied Pythagoras theorem. So according to theorem, it says hypotenuse square, right? According to Pythagoras theorem, hypotenuse square can be written as sum of adjacent square plus opposite square. So with which you can find the distance of AB. Okay. And there are another case where the points, whatever the 2 points we take, does not lie on x nor on y-axis. That means the points are somewhere floating on the coordinates. Let me take this as P and this as Q. Somewhere on the coordinates. Now we are supposed to find the distance between these two. So whenever you want to find the distance between the point PQ, always draw with reference to x-axis. So I am taking a perpendicular line to x-axis and perpendicular line from the point to x-axis. You can name it with S and T, whichever is okay for you. Fine. And also you need to take the perpendicular line with respect to parallel line with respect to y-axis. Okay. And you can see here it is an intersecting point. Let me take it as R. Now you can see this forms a triangle. Okay. So you have seen the different cases on x-axis how to find the distance, y-axis how to find the distance, point joining x and y-axis how to find the distance. Points are nowhere related to x and y, but still we can find the distance. And points are in two different quadrants where you can find the distance between the points. So these are the different cases where we apply the distance formula. But every time we will not be able to figure out the values of the correspondence with reference to x and y axis when it is a larger problem. So in that case we have to go for a standard formula, which is what we are going to study, distance formula. This formula will help us to find the distance between 2 points on whatever cases. As we have already discussed, the cases can be anything, but still you will be able to find the distance between the given 2 points. So this triangle can be solved and find the value of PQ by Pythagoras theorem. PQ square can be written as the hypotenuse square is PR square plus PQ square. So let us consider one more case where the points are nowhere related to one quadrant. One point is in the first quadrant, another point is in somewhere other quadrant. So let us take that example also. Okay, y and x axis point as origin. So let me take one point P on the x axis on the first quadrant and the another point Q on the third quadrant. I need to find its longest length. To find this, as I told you, whenever you want to find any point which is nowhere connected to x and y axis, take a perpendicular line or parallel line with respect to x and y axis. So the intersecting point of the point P and point Q, this I will denote it as some other T or S, and this is intersecting here also, it is T, and this point Q is intersecting here, let me take it as R. So now this forms a triangle where the solution can be obtained by Pythagoras theorem. PQ square is equal to PS square plus QS square.